Hi everybody, this is Dark Guardsman. We're back with part 3 of item-based energy storage. Now, last episode we went ahead and got some code started working on getting the wrapper that's necessary to access the energy in the items that we have. Now, I went ahead and got a little bit of code started here, and mainly due to having to re-record this a couple times. But what we're doing right now and what we did previously, so what we did previously is we set this up, got this kind of going, and we were talking about doing an iterator, and then I got interrupted and we had to continue back off again. Now, the iterator is a really basic concept. It's effectively what allows these for loops to work as it is. It's effectively you're iterating over objects. For those who've never taken a Java 101 course or anything like that, it works pretty basic. What it does is the for loop will ask, do you have another next object? If it returns yes, it'll ask for the next object. Then you'll move forward or you'll iterate forward to get to the next object again, so that way it can go over and over again. Once you return false on has next object, it then stops iterating and the for loop exits. So what we want to do is, because we made this iterable so that way we can iterate over ourselves, we now need to make it so that way we can actually have the iterator itself. Now, the iterator is going to take in our inventory, and it's effectively going to search for power items in the slots. Now, in theory, we should always have power items in the slots, but never assume that's how it's going to work. Something could break, something could happen. You could end up with an item in your slot that you do not expect. Always want to make sure you sanity check data. So that's what we're going to do, is sanity check. Now, for the has next, what we're going to end up doing is we're going to go one item at a time, and we're going to assign the current slot. Actually, the current slot is going to be based off of the next, or effectively when we call next, we're going to grab the current item in the slot. So we're going to do item stack equals inventory dot get stack in slot, and this will be the current slot is what this will be. And then what we'll end up doing is we'll assign current slot to next slot, and then we'll return item stack. This is theory how it's supposed to work. And the reason why we want to kind of do this is this allows us to do other things later. It's not exactly necessary. You can actually get away with next slot. And then we'll go ahead and implement this. And then in theory, what you'll also do is do next slot plus plus. I'm doing this all by memory, and it's been a while since I've been able to implement one of these. And so we'll do this, and actually we don't want to be returning that, or returning item stack. Let's return null by default. Theoretically, we should never actually have null come out of this, but we're going to have to do that anyways, just because you're not going to have a perfect situation. We would go item stack dot has capability, and we're looking for capability energy dot energy. And we're going to have to return null on the side. So that should in theory have a capability, and then we're going to return item stack dot get capability. And we're going to grab this bit. So theoretically, this should work, because in the has next function, we should already check this, which we're going to do here in a second. I just got to make sure that the has next actually does result in a proper ID. Oh yeah, has next would be less than inventory dot get. I think it's a get size. We're gonna have to check this. So in theory, what this should tell me is, oh yeah, get slots. I don't know why they don't call it size. That's weird. Okay, so get slots, so that should be able to tell me my limit. So I should have a lower limit of 0 and upper limit of slots. That's kind of how it's supposed to work in theory with the inventories. So now what we want to do is grab what's in our next slot. So for next slot, it has some kind of value. I wonder if this is the point where we could actually do next. Yeah, so this is what we'll do. So if next slot equals -1, actually no, we can actually leave next slot as 0, because that's going to be our first slot. So we want to do, we effectively want to, every time something calls has next, we want to effectively do the same check we did down here. So we want to grab this, and we want to run this call. Because the state of the system should never change, in theory. This is not exactly how this works. You could actually have it where you call a method multiple times and you never get the same result, which is the definition of insanity. So we got storage, and what we effectively just want to do is we want to go return true if return if storage doesn't equal null is what this should be. Actually, we do it this way. If storage doesn't equal null, then we want to return true. And then if else, we want to try to find an entry that's good. So else, we basically want to go while, and we want to turn this into reusable methods. Thinking about this guy is something I really should have planned out when we did this entire episode here, but we really need to make a reusable method. So we public energy storage, and we want to get index, and we want to put this code into there, return null, and we'll make sure the index is actually running right here. So you get this object in this slot, and also we probably should be doing this as well, is empty, and not empty actually, just to kind of, because if it's an empty thing, you might as well not check capabilities on, it's a little faster. And then what we could do right here is actually get the energy storage, and we can actually just call get, and we can call current slot. I think we just need to do this, because if you call next, no, we do need to iterate forward. Okay, so now with this code up here, we can do more or less a do while loop. Something like that. And what you want to do is if get next slot equals null, then effectively you want to do next slot plus plus. This is not exactly the best way to implement this. There's definitely probably a cleaner way. Yeah, there's definitely a cleaner way. What we can do instead here is put this here and do that. So if, as long as this equals null, then we want to increase the next slot. I don't know, why is it doing that? So as long as this equals null, we want to basically next slot, so on and so on, until we find a slot that is not null, and then we want to make sure we return that. And then we got some safety checks here to make sure that next slot's above a certain amount and less than our slot ID, because we don't want to return if we hit the end of the limit, and that's our cutoff point. So this in theory should work, and we'll be able to test this in a second. Let's go ahead and implement the rest of the code here. So for the receive, we just want to keep pumping energy into the batteries until we run out. So we're going to basically charge first come first serve, and we just want to keep track of the amount of energy we actually charge. So this will be storage dot, and this will be receive energy, and we want to make sure we actually have a tracker for how much energy we have left. Energy left equals max receive. And we'll do int added, this will be receive energy, and then we'll do energy left dot simulate. So you want to make sure you can simulate or not, and then once we add something, we're going to go energy plus equal added. We don't need to do any sanity checks ourselves because we don't have a limit on the max receive, and it's everything else. The batteries themselves will be our limit on that. And then we make sure energy left is minus by the amount added, and that should in theory work. And then we'll return the amount of energy actually taken out of it, and then we'll slowly drain the energy until we run out of energy to store. And then we just basically do the same exact thing here, except we're going to do max extract. This one's a little different. It should in theory run the same way, just got to change the names here. Energy to remove. And then we basically, energy, so that'll work, and then we just change the method to extract energy. So this should keep removing energy until we removed enough energy to satisfy the demand. And of course it'll hit the limits on the stuff. So if we can only take out so much power out of each item, it should result in the behavior we expect. So that should be all the code right there. So we've got our receive energy, which will drain or add energy to each item, extract, which will remove energy. We can then check the storage, we can get max storage, everything else, and that should work for our capability. Now we just need to add this capability to the system, so we just need to go if battery wrapper equals null, then we do battery wrapper dot equals new inventory energy storage, and then we want to pass in get inventory. And that one's an IM handler. So this is going to be external inventory. There we go. That should work. I'm still using some ancient code on the external inventory that I have yet to use or remove. iInventory has basically been replaced by item handler. So this just works. We have an inventory, we have a battery system. We're now going to need a GUI, which I'll go ahead and cover in the next episode, which we'll get into actually testing and everything else and actually finishing this off.